Raoult law states that the vapor pressure of a solvent is always greater than the vapor pressure of the same solvent in solution state. We derive an expression for Raoult law. P is vapor pressure of solvent, any particular solvent in solution state, where P naught is the vapor pressure of solvent in pure state. So according to this expression, the vapor pressure of a solvent in solution state is equal to the vapor pressure of the solvent in a pure state multiplied by the mole fraction of the solute. In other words, we can say that vapor pressure basically refers to the formation of a vapor. If we have a pure sample and here we mix the sample with some solute which must be non-volatile, so it is solution of the sample. So here the vapor pressure, which is P naught, will be high. In other words, the formation of vapor in this case will be high. But as far as the solution is concerned, here the vapor pressure denoted by P according to the above expression, it will be low. So why is the distinction between the two cases? When we have a pure sample, then there is a greater area for a solvent molecule to evaporate, but once the solvent is mixed with some solute, especially non-volatile solute, that reduces the surface area for a sulfur molecule to evaporate. So that's why we can say that in solution state the chance of evaporation reduced. So that's why we apply here Raoult law to explain the lowering of vapor pressure. So here in solution state we observe lowering of vapor pressure. And this is a colligative property. This is a colligative property, especially those properties which depend upon the number of particles, but independent of their nature, are known as colligative properties. Besides lowering of vapor pressure, we also noted that elevation of boiling point, depression of freezing point, and osmotic pressure. All these are examples of colligative properties. We can demonstrate the lowering of vapor pressure here by a figure. Here we have a solution in which the vapor pressure of a particular solvent has just reduced in pure state. This is pure state where the vapor pressure is higher. So in solution state the vapor pressure is always less than the vapor pressure of a solvent in pure state. So this is all about lowering of vapor pressure explained by the Raoult law. In Raoult law we derived an expression delta P is equal to P naught x2r, delta P or P naught is equal to x2. So these are two important expressions, especially delta P and delta P over P naught. This is lowering of vapor pressure, and this expression tells us the relative lowering of vapor pressure. The lowering of vapor pressure is equal to the vapor pressure of a solvent in pure state multiplied by the mole fraction of solute. But as far as the relative lowering of vapor pressure is concerned, it is equal to the mole fraction of solute. Or in other words, we can say that if we increase the quantity of solute, then we will observe a greater degree of lowering of vapor pressure. As far as the calculation with respect to lowering of vapor pressure is concerned, so we can calculate molar masses from these relative lowering of vapor pressure. We have an expression which can be used for calculating the molar masses of especially particular solvent, where we observe the relative lowering of vapor pressure. For example, if we consider this equation, so this can be written as N2, which is number of moles. Either number of mole can be written as or this can be written as further we can rearrange it W2 M1. So the net expression for M2 will be deduce here, M2 will be delta P or P naught plus W2 M1 or W1. So here